Okay, think about what that'll look like. If you have a constant function, okay, so if you have like your little graph, and then you graph y equals c, or let's make up a number. How about like 3, okay? So if you had to take the derivative of just straight up 3, okay, that's the same thing as if I graphed y equals 3, okay, I have to find the slope of the tangent line, right? So the slope of this tangent line, the slope of a horizontal line is 0. So every constant, the slope of that line is always 0. The derivative of it is always 0. Things to watch out for is they'll try to be mean and they'll say, what's the derivative of pi? And you also have to say 0 because it's a number. So any number, derivative equals 0. So don't forget that derivative is a slope of the tangent line. Okay. Tangent line. Okay. So power rule. So this is the little trick. Okay. So if you're taking a derivative of a polynomial, okay, so x to some power, okay, what you do is you're going to bring down the power and subtract. Okay, so I'm going to do some examples because with the variables, it looks all scary looking. But basically, you bring down the power in front, okay, and then you subtract 1 from the previous power. So we'll do some examples, so don't worry. That'll make more sense. These are little constant multiple rules. All these are pretty intuitive. So like if you are taking a derivative, you could take the derivative of just the x business and then multiply by the number. Addition, you could do the derivative of each of them separately. Subtraction, you can do the derivative of each of them separately. Not multiplication, not division. Okay, so limits, you know how you can do it all with multiplication, division, everything? Derivatives, no way, Jose. Okay, so you could do sum and difference, but not multiplication and not division. Okay, so you can break them up basically. This we talked about at the end, but like the derivative of e is e. So that's the best one because it's just the derivative of it is e. The definition, this hasn't been coming up as much. Sorry, I kind of skipped over here. That hasn't been coming up so much on the AP test, so we're not going to worry about that. We might go back to that at a different time in the class. This is also another one. We're going to go through that one more too. This is for like if you had to take the derivative of 2 to the x. The derivative of that is 2 to the x natural log. Oh, that's bad. That's an A. That should be A. Ooh. Natural log 2. Oh my gosh, that's so bad. That's wrong. I gotta change that. Make sure you change that. That's supposed to be an A. Whew. Jeez. That's horrible. Okay. We'll show you. I'll actually show you the proof for that later on when we get to it. That's in like day 9 or something like that. All right, so this is so fun. You guys, like, this is my favorite stuff because it's so fun, okay? So it's really numbery. I love it. You guys are like, oh no, you know me so well. You're like, oh no. Okay, so everything is fun. Okay, well, the derivative for these are fun, I promise, okay? So what you're going to do is you're going to take the power, okay, whatever the power is, and you're going to bring it down. Okay, so what does that mean? You're going to have 10, and then you're going to multiply by that 4, which is the power you brought down. And then it's going to be x. And then what you're going to do is you're going to subtract 1 from the power. I'm going to show an obnoxious amount of work right now. You do not need to show all of this. You could go straight to 40x cubed if you want. Okay, so you're going to bring down the power. So you're going to go 4 times whatever number's in front. Okay, and then you're going to decrease the power by 1. Okay, I don't know if you noticed, like when you were doing this, the matching the graphs, like the derivative of a parabola, an x squared function was a line. Okay, that's because of this power rule and how derivatives act. Okay, so that'll be the first one. The next one, you have 2, and then you're going to bring down the power 3. Okay, and then you have x, and then instead of 3, it's going to decrease by 1. But again, I'm just showing like a crazy amount of work just because you see that better. And then this one, the minus x. So like for this one, there's like an exponent. The exponent on x is a 1. Okay, so if you bring that 1 down, you get 1, and then it's x to the 1 minus 1, which ends up being 0. Okay, and then grand finale, the derivative of 6 is just straight up 0 because it's a constant. Okay, so you basically take the power, multiply it out front, and subtract 1. So usually when I do derivatives, I'm not showing all that work. I'm kind of doing it more like I'm going to go 4 times 10, 40. And then instead of 4 now, it's going to be cubed, 3. Okay. Then this next one, I go 3 times 2 is 6. And this would be it decreased by 1 squared. Okay. And then this one, this last one, people get weird about, but like, think about this one. This is x to the 0 power. So this one just turns to a 1. Okay. So when it's just plain x, it's going to be a 1. Things you can kind of think about. Remember, it's a slope of a tangent line. Think about if you had to graph y equals 2x. The slope of that line is 2. So like for an x, it's always just the coefficient because it's just the slope of the line. Okay? Any questions? Okay. This one was a little bit of child's play, okay? Because we like to do some fun ones, okay? No, this is where the fun starts. Oh my gosh, you like knew exactly what I was going to say. Okay, now this is where you got to be careful, okay? You cannot just start taking derivatives of everything because right now it's multiplication, okay? Multiplication doesn't work with derivatives. It's a different rule, and it's more complicated. So that'll be tomorrow. Woohoo! So what you have to do is you have to make it look like addition or subtraction. So how do you do that? We'll just distribute it, No big deal. And then you're like, I love those kind of exponents, right? So you get 2t to the 2/3 minus, ooh boy, ooh hoo hoo. Okay, so remember, here maybe we might have to write that off to the side. For the exponents, you have to take, why is this so fat? There we go. 2/3 plus 1/4, right? Right, because you add the exponents, right? So you need a common denom. Okay, so 4, 8, 3, right? So that'll be 11/12. Ugh. Okay. It's a good time. Now it's subtraction, so it's good. No? Here, I'm doing 2 to the 2/3 times t to the 1/4. So I'm like trying to figure out what this new exponent is because I have to add them. So I just did a common denom. Okay. And did we even do a deriv yet? No. We didn't even do the derivative yet. Okay. So for the derivative, you're going to take 2 times the new power. So maybe I'll just do this one again. You bring down the power, and then it's t to the 2/3 and then minus 1. So you're always subtracting 1 every single time. Then you're going to bring down the power, 11/12, and then t, and then you're going to take that 11/12 and subtract 1. So it's just fraction work for these guys. So this kind of gross one, but that's fine. Okay, so we get 4/3 t to the negative 1/3, right? And then 11/12 t to the negative 1/12. Okay. And then you got to make it so there's no negative exponents. Okay. So then for it to be your grand finale, you would do 3t. You could put it as cubic roots and stuff like that. Usually, I've seen it interchangeable. Like I've seen the exponential, like the exponents be fractional, and I've seen them written as roots. So as long as you know the difference, you're going to be fine. Because these are usually multiple choice questions. If they're on FRQ, they're going to make you do stuff with it. Not this one. This one's too sassy, I think, for an FRQ. If you're going to do like some physics or some particle motion or all that kind of thing. Okay? All right. Look at that one. Woo! That's scary. Okay. So I tried to throw all the scaries at you in one problem. Okay, what is G prime? What is dg dx? Okay. So are these, how do I do this one? What do I do for that? What does this mean? Derivative. Okay, what do I do for this one? What does this mean? It's not a trick question, I promise. What does that mean? dg dx. What does that mean? Yeah, derivative g with respect to x. Are these the same? Yes. Same. This is the same thing. Different notation, okay? So g prime of x is the same thing as asking to find dg dx. Okay, it's just like a different vibe. It's because they have a petty drama against each other, Newton and Leibniz, okay? All right, so I have to take the derivative of that psycho thing. I'm first. Now, there is no judgment here because we need to get the right answer every time. So I'm going to write this as x to the negative 1/3 because in my brain, that makes me feel better when I'm doing derivatives, okay? So I'm going to rewrite this, e to the x, I don't know what that is. This looks messed up. I'll deal with that later. Plus e cubed plus 2 to the x. So I guess I really needed that first one to look more normal for me. Because when I do a derivative with power rule, I have to bring down the power and subtract 1, right? So if I do a derivative, my answer to that one would be negative 1/3, right? X to the negative 4/3. Can we do that right away? Subtract 1. Okay, so I subtracted 1. So that's power rule. Now, and it's all addition, so that's why we're all legal here. What's the derivative of e to the x? Yeah, Spider-Man guy. Okay, so e to the x. That's my favorite one. Okay. Now, this other one I just put on there to mess with you. Okay. Now, x to the e power. Okay. Now, this is 2.7 blah, blah, blah to the x. This one's x to the 2.7 blah, blah, blah. So you actually treat this guy the same as this one, right? So it's the same power rule. You're going to bring e down, and then your exponent is super messed up. Well, not super messed up. It's just kind of like, what? It's literally e minus 1. Let me erase that bar. It's hard to see this now. Go away. Okay. So I brought it down, subtract. Okay. Now, here's another e thing. E cubed. What's the derivative of that? Is that e cubed? 2.7 to the third power. What is that answer? A number, right, is a constant, so it's 0. Okay, so this is 0 because this is a constant. Again, I'm giving you all the SAS ones, right, in one problem. Okay, now this other guy, that's that fancy one. I'll prove it to you why it works later, but for now, I would just put it in your brain. So 2 to the x, this is a shoot out of your brain one that you just memorize and know, okay? So this guy, the derivative is an I need to know one. Kind of like how e to the x, the derivative of e to the x is always e to the x, okay? That one's like I know that in my brain. This one, the derivative is you rewrite it and then multiply by the natural log of the base. And that's a pull out of your brain one. So if it was a 3 to the x, you'd write 3 to the x, natural log 3. If it was 4, you write 4 to the x, natural log 4, blah, blah, blah. Okay. And then now we're going to rewrite it to make it look cute because we have a negative exponent, which looks gross. And the plus 0, that looks lame. Okay. Look at this is how you know it's a good one because your circle is like a huge oval for your answer. Is there any questions? Can I throw them all at you? Okay. It's not even a circle, it's an oval. Okay, what does that thing mean? What does this mean? Second derivative. Yep, so you're going to find the second derivative. How do you find a second derivative? You just look at this and take the derivative again. Okay, just do it again and again. Just kidding. You could do 3 of them. That's jerk in physics, you physics people. Okay, so now we're going to do second derivative. What color am I feeling? Green. Okay, so what does that mean? I'm going to bring down the negative 4/3. So that's going to be 4/9. Negative 1/3 times 4/3 is 4/9. X to the negative, what would that be? 7/3. Okay, so bring it down, multiply it, and subtract 1. Then my fave, derivative e to the x, e to the x. Okay, this one's super messed up. Plus, ew. How do I even do that? Because I got e down there already, and now I have to bring down that exponent, which is disgusting. So it'll be e times e minus 1. This is a hard one. That's a hard one. Right? Because I bring it down. Well, wait, what's my new exponent then? I have to e, it's e minus 1 minus 1, right? Yeah, so e minus 2. Ew, look at that thing. Gross. And then this last one, yeah, that's pretty rough, but that's fine. This is a later problem. Later. That's too hard. That's going to be a later problem. Okay. If you were wondering, that's the answer, but it's natural log 2 quantity squared times 2 to the 2x. So, okay. But that's a later problem. Okay, if you had to find g prime, we'll just do this first one. You're just throwing the 1 into the derivative. So g prime of 1 is just like how you do normal function notation. You're just going to throw that in. So you're going to throw in the 1. That's kind of ugly, isn't it? Okay. This is where I wish it was, what are we doing? What is this? This would be negative 1/3 plus e gross plus, what the heck is that? E, right? 1 to weird stuff is still 1, so that's e. And then this thing, 2 natural log 2. So I guess I can say I've got 2 e's. right? That's disgusting. That's okay.
Why is it just plain E when you do that? The second.
This one? This one? Or this one?
That one.
Because if you take 1 to any power, it's always 1. Like 1 to 56 is 1, 1 to like -2 is 1. Any power, 1 to any power is always 1. And then I did 1 times E. So I just got E. No, please ask that stuff. Mm-hmm. Yeah.
I need words.
Okay. All right, we can skip that one. Let's do B. We got to freak you out if there's no X, you know? It's part of the fun. Okay, so do you know what's going on between those two? You know, the numerator and denominator, that's called division. Hey? So you'll learn quotient rule tomorrow. It's very painful. Okay? Quotient rule is painful. So when you can, you should mess with it. Okay? So, you ready? This is math tricks. U to the -1/2 times U plus 1. What? Look at this math stuff you can do now. This is why you learn all of high school math before you do these things. Okay? So, I brought it up. You could just divide each of them separately. Another way you could think in your brain, I don't know which brain you're like, you could do this. Do you know what I'm saying? Either one. It's the same thing. I just don't like rational exponents like that personally. But whatever you do, you need to change it into not division. So what I'm going to do is I'm going to distribute that. So what would that be? U to the 1/2 plus U to the -1/2. Well, now it looks cute, right? Kind of. And then this is what happens. Someone circles it. I'm like, what? You didn't even do a deriv yet. You got to do the deriv. Deriv is the cool way to say derivative, just so you know. So, okay. Because I did 1 plus 1/2. Yeah. No, please ask that, because. Okay. Now we're going to deriv. So bring it down, subtract 1. Bring it down, subtract 1. Okay. Bring it down, subtract 1. And then you're going to make it cute with the negative exponents out of there. Okay. Always got to keep her cute. So 1 over 2. If you want to write root U, I guess. It doesn't matter. I really don't care. I'd rather just keep it an exponent, but that's me. That's a direct. What question?
Why is when you distribute it, why is U like the first U like 1/2 not -1/2?
Oh, because when you distribute, you have to add them. I think you're multiplying them. Because you would add -1/2 plus 1. It's like if you did x squared times x plus 3 or whatever, it'd be x cubed. Because you add them. Yeah. No, when it's like rationals and fractions, you're all like, "Wow, it's harder for sure." So, all right, questions? Exponent rules to the max. This one takes 5 seconds. Do you know the derivative of that? 5e to the x. Yeah. The reason is do you know what the death is? Here, I gotta get the dry blood. Hold on. Dry blood. Doesn't it look like it? People do 5x e to the x minus 1. You see the brain? You get the brain, though? But it's not. It's bad. You have to think Spider-Man. Do this. Actually, maybe don't do that, because then... Okay, never mind. Going crazy. Oh, this one just makes me... Okay. This one drives me insane because it's like an algebra concept. Okay. So the derivative is actually easy on this. It's like what people mess up is they write it wrong. Okay. So what I would do, because you've got negative exponents to start, change this to 3/5 x to the 7th. It's for your sanity. Just kind of put the numbers up front. Okay. Minus, change this to 3/4 x to the negative 2. Okay. So throw your numbers out front. Okay. Plus, and then this is the last one. This is when people drive me insane. They'll say it's 14x to the 5th. So you just like throw the 2 up there. Okay. This is 7/2 x to the positive 5. So when you have a negative exponent on the denominator, put it on the numerator and make it positive. And then the derivative you could just quick do. Why don't you just quick do that? The deriv. Now do the deriv. Oh my gosh. Dumb. You got the deriv? Then it's fun. That's when it's fun.
That's what's fun. When I'm correct, it's fun.
Yeah. Are you ready for the reveal? Or no?
I'm ready. Drum roll.
Dun dun dun.
Okay, boom. Okay, boom.
Okay, so you should have 21/5 and a 6. Positive 3/2. Okay, positive 3/2 because you have a negative 2, negative times negative, then to the negative 3 power, and then 35/2. And then to make it cute, that middle one, you got to put the x cubed down there. Okay. Okay. We'll do one more, then we'll be calling it. One more because we have to make sure.
Which one is more fun?
Actually, I kind of have to do 2 of these. Shoot. Okay, we'll do this. Do you know what this means? Horizontal tangents. What does that mean? Okay, horizontal tangents. Tangents make it a calculus question. Okay, horizontal gives you a little edge, gives you some extra stuff. So what does it mean if there's a horizontal tangent on a graph? Slope is 0. Not just any slope. The slope of the tangent line. Okay, so what does that mean? That y prime equals 0. So tangent means derivative. Okay, derivative. Horizontal means it equals 0. So I wonder what we should do. Every single calculus problem, if you're ever in doubt, this isn't a joke. Whenever you're in doubt, take a derivative of something. You'll probably sneak a point. That's the goal, okay? So what we're going to do, you got that function, not sure what to do, take a derivative of it. Seriously, I'm not even joking. Just do it. Take a deriv. Y prime equals, what would that be? 4 minus e to the x, hey? Deriv. Derivative of 4x is 4. Right?
Yeah.
And then derivative of e is e to the x, right? Oh, yeah. And now I'm going to set it equal to 0. And then you do math. Okay. So then you're going to subtract 4. I mean, I don't know how much algebra we need to see, but. And then this, it's like, how do I solve for that? Oh, thank goodness I did Unit 1. Okay, and took high school math because you just need to take natural log of both sides. Okay? It's just random when you have to do math things you know. I'm serious. Like, it's just kind of like solve for x, use anything you've ever learned, just do it. You know what I mean? That's like how this class is. So what you're going to do is you're going to take natural log of both sides. Because if you take the natural log of e to the x, they undo each other. So you're left with natural log 4 equals x. So those are your x values. Do you know what F or Q or multiple choice is going to be mean? That won't be an option. Do you know what will be? That. Do you know why? I'm scaring you now. Because isn't 4 2 squared? Isn't that sass? It's sass. They're going to be mean. Okay, there was 1 year no one in the world got 100. It's usually 2 a year. 2 people get 100% in the whole world. It's not a joke. It's not a joke. I know. Because they get full rides at college. Oh, yeah. They should get a full ride at MIT for sure. Oh, yeah. They get on the news.
Really?
Yeah. You get on the news. If you get 100. Okay. All right. Yeah. Yeah. We need one. We need one. At least one. Okay. I know. Okay. Now, this question. What is an equation of the line? What is the equation of a line? Do you know what that means? Equation of a line? It is throwback to algebra. Y minus y1 equals m times x minus x1. What makes it calculus? Tangent. Okay. Okay. So what is going on? We've got a function. I'll probably take the derivative of it. Probably. Okay. At the point where f prime equals 3. Oh, well, this is a little wild. Because they're saying the f prime equals 3. Is that going to go x1, m, or y1? Where's the 3 go? Because that's one of them. It's the m. They give us the slope. Yay. And then it's short-lived because we don't have any of the other two. So that's a little depressing, but that's fine. Okay. I'm not sure what to do. Let's take a deriv. 4x cubed minus 6x. Sorry, I can't. I did that too fast. I did 4, bring the 4 down, x, and then subtract 1, 3. Then I did 2 times 3 is 6, subtract 1, and I didn't write the power 1 because it's like kind of janky looking. You know what I mean? Okay. Yes! Well, look, there she is. You can do that, and you can solve for x. Okay? Now, don't be weird and start factoring. You can't do that. You got to scooch the 3 over and do some zeros, or you could do calc intersect. I actually didn't do this in my head earlier, but what you would do is I would probably do zeros. And I would put this in y1, and I would do calc 0 and get those x values, which I don't even have my calculator. Actually, now I do. You guys should do it quick because Oh, da da da. Oops, 4x cubed minus 6x minus 3. It's like 1.5-ish or something. Come on, second calc. Jeez Louise. 2. 1.4236. Okay, that's a beautiful x. So we're going to throw that in. Okay, what are we missing? Y. Where do I get y? Yes. Okay, so y prime, or y sub 1, I mean, f of the psycho number into the, so you have to raise it to the 4th power minus 3 times. I'm just plugging it in. Yeah, because if you plug in the derivative, you're going to get 0. Ugh. I need more room for my y. Is that what you got? That's what I got. Okay. And that's your equation of a line. Don't solve for y. It's a waste of life. Just leave it. Beautiful. Sorry, that was a long one. Product and quotient tomorrow.
That was so fun.
It was fun.